Hey guys, it's Mrs. Conway. So, systems of equations, we've been solving them with graphing and guess and check. And here's the deal. That doesn't always work. I mean, graphs are kind of limited in what they can do, and also can't always make a graph. It's not always convenient. So we're going to learn how to solve systems of equations algebraically, and there's two ways to do that. One is substitution and the other is elimination. We're going to start with substitution, and then we'll go into elimination. Both methods work for any system. Sometimes it's easier to use one, sometimes it's easier to use the other, but you might prefer one over the other and just stick with the one you like. So I'm going to teach them both to you, and you can choose which one you prefer. So substitution, I'm going to start by going over the transitive property of equality, which is something you should have already learned about, but we'll just remind you. It means that if A equals B and B equals C, then A equals C. Okay, it's basically saying if two things are equal to the same thing, then they're equal to each other, which hopefully makes sense. That means that if we have two equations that are both solved for the same variable, we can use the transitive property of equality to make one equation. So what we're going to do is we're going to take an equation that looks like y equals something, and another equation that looks like y equals something, and since they're a system of equations and we're trying to find where they're both true, we're going to just eliminate the y's and make them equal to each other. So if I have y equals negative 8x minus 23 and y equals 6x plus 19, I'm going to rewrite that as y as negative 8x minus 23 equals 6x plus 19. So see, I just made them equal to each other because they both equal y, so they should equal each other. Now, hopefully you remember how to do this. This is first trimester stuff. I'm just going to get x by itself. So I'm going to subtract 6x from both sides. This is that thing where you can draw the dot, dot, dot. So I have negative 14x minus 23 equals 19 to both sides. And that is, so then these cancel, and I'm left with 42. Divide both sides by negative 14. X equals 14. That should go in 3, and it is a negative 3 because I know that that's not a very good 14, but that is a negative 14. So you've got positive divided by negative is negative 3. So x is negative 3 because we just found x. This is a system of equations. That means that we're trying to find where these two lines cross. Well, they're going to cross at a coordinate point, x, y. So it crosses at negative 3 for x. How do we find that y? Well, we have to plug negative 3 in for one of these x's. It shouldn't matter. You should get the same one no matter what. So y equals, so step 1, we found x. Now we're going to find y. I'm going to do y equals negative 8. I'm just using this equation. Parentheses, negative 3 minus 23. And then I just have to do that math. So y equals, that's going to be positive 24 minus 23, so y is 1. So that means my final answer should be negative 3, 1. And then I should just check it. So I'm just going to take my calculator. I don't even really need to check the first equation because that's how I got that. I'm just going to check the second one. 6 times negative 3 plus 19 is 1. So if I put x in for this x, I get 1 out, which just matches this point I have. So my final answer is negative 3, 1, and that should be the solution to the system of equations. So that's all we do here. And you might just look, I'm just going to show you here, I wouldn't graph those. Negative 23, 19, those are massive numbers. That would be a really big graph. It'd be really hard to graph, and then it'd be kind of hard to see where your solution was because they'd be so far apart. So it'd be such a big graph, it'd be hard to zoom in. So if you think you get that, try the next 3 problems and hit pause and then try them and see if you can get it. If you're still like, watch me do another example, and then maybe you can try on your own later down the problems. Hey, so hopefully you've had a chance to try out question 3. So question 3 is y equals 6x plus 11 and y equals negative 2x plus 3. And these are all going to be basically the same steps. So I'm going to start by putting these two together. So you have 6x plus 11 equals negative 2x plus 3. Now I'm going to solve for x, add 2x because that's a negative 2x. And then that's 8x plus 11 equals 3. Subtract 11 on both sides. Sorry, that's plus 11, so I have to subtract 11 on both sides of the equation. 8x equals negative 8. And then whenever you have a number in front of x, you divide by that number. So x equals negative 1. That's a negative 1. All right, so I've got x. Now I have to find y. So I'm going to take my first equation. Y equals 6, but instead of x, I'm going to put negative 1. 6 times negative 1 plus 11, which is negative 6 plus 11. So y equals 5. And then I put it into a point, negative 1, 5. And then I just check. I basically got it from here. So negative 2 times negative 1 would be positive 2 plus 3 is 5. So it works. Okay, if you haven't paused it yet and worked ahead, I encourage you again to try out numbers 4 and 5 on your own. Hit pause, and then when you're done, see if you got it right. So for number 4, hopefully you've had a chance to try it now. For number 4, you're going to put the two equations together. Negative 2x plus 18 equals 3x minus 17. That should be a 17, not a 12. Okay, and then remember dot, dot, dot down the equal sign. You do it to one side, do it to the other. I want all my x's on the left, so I'm going to minus 3x from both sides. You could add 2x on both sides and then get the x on the right. That's your call. I just like to always get x's on the left. But some of you might rather have positive numbers. So that's negative 5x plus 18 equals negative 17. Subtract 18 on both sides. Negative 5x equals negative 35. Divide by negative 5 on both sides. X equals positive 7. Okay, now I have to find y. I'm going to use the first equation. Again, it doesn't matter. You could use the second one if you wanted. Y equals negative 2 times 7. Negative 2 times 7 is negative 14 plus 18 is 4. Then I just want to check. 3 times 7 is 21. Minus 17 is 4. So 7, 4 works for both equations. So it's the solution. Okay, last one. Maybe you've already tried it out. I'm going to start by putting the two equations together. 6x minus 16 equals 3x minus 7. Dot, 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 dot down the middle. Subtract 3x on both sides. Those don't cancel. These cancel. That's 3x minus 16 equals negative 7. Add 16 to both sides. X equals 11. No. 3x equals 9. Negative 7 plus 16 is 9. Divide both sides by 3. X equals 3. Now I'm going to plug 3 in for x in one of the other equations. Y equals 6 times 3. Y equals 18 minus 16, so y equals 2. So my point should be 3, 2. Again, just check. 3 times 3 is 9, minus 7 is 2. Good. And I could check it back in here. 3 times 6 is 18 minus 16 is 2, but that's how I got the 2. So, all right, so those are what you should have got for those 4. If you're getting this, it's time to go work on Delta Math. So you get to practice a few more of these and do some review. If you have trouble, again, just a reminder, go to office hours. So good luck.